Hello, this is for the Tuesday, Thursday class, January 21st, and the Monday and Wednesday class. This is your lesson for Monday the 25th. So let's get started. All right, so in this section, we're going to talk about translating phrases and algebraic expressions. So these words that are here on this chart, you should be familiar with. So if I'm asking about the sum of two numbers, you need to know that that means addition, okay? The difference, we're talking about the difference of two numbers. That's under subtraction. Product means to multiply. Quotient, that means you are dividing two numbers. And if we're talking about powers or the square of or the cube of, we're talking about exponents. So I circled or underlined a few main terms, but really you need to know all of these terms. So if I said 5 less than 10, you need to know that you are subtracting. Also, one of the things about subtraction and division especially is that the order of the numbers is very, very important. If you add or multiply two numbers and then reverse their order, you're going to get the same answer. For example, 5 plus 7 equals the same thing as 7 plus 5, right? Same thing with multiplication. However, with subtraction and division, the order will influence the answer. So if I said 5 minus 7, I do not get the same thing as 7 minus 5. So as we go through this, when I talk about the order that you have to write these particular phrases, it's very, very important. All right, so let's look at a few. So the main phrase I want you to be familiar with is less than, okay? So less than is one where you take the way it's written and you reverse it. So 3 less than a number. So usually you can use whatever variable you want, X or Y. If you're in HOX, it tells you what variable to use. So make sure you read the directions carefully because you have to use the variable that they recommend for you. But if I say 3 less than a number, you start with your unknown number and you subtract 3 from it. Since this is subtraction, if you wrote the 3 first in this particular phrase, that will be incorrect. Okay, so less than is probably the main phrase. There are a couple of others, but this is the most popular phrase that you have to know, that you take the order that is given to you and you reverse it. All right, the next one is the sum. Sum means addition. So the sum of a number and 4. That just means we're adding a variable and 4. A number divided by 3. So you have to put this in the right order. It's division. So a number, whatever number you start with, divided by 3. So you can write it that way, or you can write it in this form. Those are equal. The ratio of a number to 7. So ratio is another way of thinking of a fraction. The ratio of a number to 7. So you can write it like that. Product means multiplication. The product of a number and 9. So multiplication, the order isn't very important. So you could always do a number times 9 this way, but almost always if you have a number multiplied by a variable, you're always going to get it written in this form. It's just 9x or 9y, either way. And so, like I said, addition and multiplication, the order can be flipped and you get the same answer. All right, up here, 6 plus a number, 6 plus a number. Oops. What did I just do? Let's go back. There we go. 6 plus a number. 5 times a number, that's multiplication. 5 times a number. 2 subtracted from a number. Now this is one, also think about that. If I'm taking 2 away from 6, I would get 4, right? So this is another reverse order, less than and subtracted from. I would have to start with the number and take 2 from it. 2 subtracted from a number, that's exactly the right order you'd have to use. A number multiplied by 7, so you could either say, use parentheses or a dot to show multiplication. Don't ever use an X to show multiplication when we're using variables. But like I said earlier, it's almost always going to be written in this form. And then for more than a number. Now, technically less than and more than is going to flip the order, but since it's addition, it's not that important. So for more than a number can be written like this or this. Both of those are acceptable. All right, translate the following phrases into algebraic expressions. Do not simplify. So we have 8 times y, comma, that means all of that divided by 5. So 8 times y, all of that divided by 5. You can put it like that, or you can write it like this. Those are equal. The sum of 2 numbers decreased by 4. So first thing we look at is the sum of 2 numbers. So the sum of 2 numbers, and then that decreased by 4. You could have parentheses there, or you don't have to, because order of operations, you do everything in order from left to right when it's addition and subtraction. 3 less than, remember less than means whatever you have, 3 less than, you take it and you subtract 3 off the end of it. Less than means reverse order. So we're going to throw this down here. So the first thing we're going to think of is the sum of x and y, the sum of x and y, and then 3 less than all of that. 3 less than the sum of x and y. The product of, so what does product mean in math? It means to multiply. We're just multiplying 3 times A times B. When you stick a variable and a number together, that just means multiplication. You can write it just like that, or you can use dots to show multiplication, or you could show parentheses. All of those are equal. All right, whoops, I did it again. And then the last one, 4 times the what? 4 times what? The sum of a number and 1, the sum of 1 and a number. This is the sum of number 1 and a number, and 4 times that. 4 times the sum of 1 and n. So hopefully that makes sense to you. Maxie's crying. He's a crybaby. All right, translating into equations. Create and solve the equations. Okay, so not only are we writing, the first ones, the ones that we just did are expressions, because these expressions did not have equal signs, and you can't solve an expression because you don't know what the variable's value is. However, anytime you have an equal sign, you can always figure out what the variable's value is. So the difference in expressions and equations is equations have equal signs. All right, so the first thing we're going to do, a number decreased by 6 is equal to, so we all know that's an equal sign, the same number times 12. So a number decreased by 6, a number decreased by 6 is equal to the number, the same number times 12, the same number times 12. There we go. All right, so since it wanted us to solve, we got to get our x's together. We have an x on both sides of the equal sign, so we're going to cancel out the smallest. Well, this is the same as 1x, so I'm going to subtract 1x from both sides. So then I would have, I'm bringing it over here, I'd have negative 6 is equal to 11x minus 1x, I'm sorry, 12x minus 1x is 11x. And then this is 11 times x. What's the opposite of multiplying by 11? We're going to divide both sides by 11. And since that's going to be a fraction that doesn't divide evenly, we're going to leave it as x is equal to negative 6/11. X is equal to negative 6/11. Leave it in fraction form if it didn't come out to be a pretty whole number or a simple fraction or a simple decimal. All right, the second one, negative 26 times a number minus 22 is, all right, so here's our equal sign, right? So negative 26 times a number minus 22, exactly how it sounds, is, what did I just do? Dang it. Okay, is 90 less than the same number. 90 less than, so remember that's reverse order, less than, that goes at the end, the number minus 90. 90 less than a number right here. All right, so we have x's on both sides and constants on both sides. So let's get our x's together. So we're going to get rid of the smaller. So negative 26 is smaller than positive 1. So we're going to add 26 to both sides. All right, so I would bring this over here. What would I have left on this side? I'd have negative 22. Bring down my equal sign. 1x plus 26x is 27x minus 90. I want this x by itself, so I'm going to get rid of minus 90 by adding 90 to both sides. So I have 27x is equal to what? 68, I think. 90, positive 90 combined with negative 22 is 68. 68, and then this says 27 times x. So what am I going to do? I'm going to divide both sides by 27. 27 divided by 27 is 1. 1 times x is 1x. And then 68 divided by 27 is a decimal. So can we just leave it like that? I guess we just leave it like that. I was trying to think if I can divide 68 and 27 by the same number, but no, I think that's it. So that's the answer. Since it didn't come out to be a pretty whole number, then let's just leave it in fraction form. Now, if they were both even, I would divide them both by 2. If they could both be divided by 3, I would have, but 68 cannot be divided by 3. So anyway, there's our x value. All right, let me get rid of all this. All right, some number plus 49 is equal to, so here's our equal sign. So let's deal with this side first. Some number plus 49, or negative 49, some number plus negative 49, or I could have just written x minus 49, is equal to the quotient of the same number and 4. So what does quotient mean? Division, the quotient of the number and 4. All right, so this is a little bit more complicated because normally I would get my x's together by subtracting x from both sides, but I have to deal with this divided by 4 first. I can't take the top away from the bottom without getting rid of that mathematically. So how do I get rid of divided by 4? I'm going to multiply both sides by 4, all right? Multiply all of this times 4. So basically what that does is cancel out that one, right? So now I have parentheses, so I'm going to use the distributive property. So 4 times x is 4x. And 4 times negative 49 equals negative 196. Or plus negative 196, same thing, is equal to x. All right, so now I want my x's on the opposite side of my number. So either I can add 196 to both sides, but then I'm still going to have an x over here, right? So I'm just going to get rid of this positive 4x. It's not the smallest, but in this situation, we want the x on one side and the other number on the other side by itself. So I'm going to bring down my negative 196. And now what's 1 minus 4? 1 minus 4 is negative 3. All right, so negative 3 times x, what's the opposite of multiplying by negative 3? We're going to divide both sides by negative 3. So x is equal to, and 196 divided by 3 is, oh, it's not pretty, is it? So anyway, it would be, we could leave it in this form, except that a negative divided by a negative is a positive. So x is equal to positive 196 over 3. Or you could say 65 1/3, but you don't have to. You can leave it in this form right here. All right. And Hawks has those crazy answers. They have weird fractions. All right, the last one, get rid of all this. The product of two numbers decreased by 8. Now that's not an equation because it doesn't say is equal to. This is an expression. So is that finished? I guess, I don't know. I don't know what I did, but anyway, this is an expression because it doesn't say is equal to or is, but anyway, the product of two numbers, so the product of two numbers, that means multiplication, decreased by 8, and that's it. There's no equation on that one for whatever reason. All right, now, this is one problem. These are the kinds of problems that you'll have in Hawks. So first of all, you need to know a couple of terms. Consecutive integers. Consecutive numbers mean they're back to back. So if I said, what are 3 consecutive months? That means in a calendar, they're right beside each other. February, March, and April. Or on a number line, it's numbers that are right beside each other. 4, 5, and 6 are consecutive integers. Integers are whole numbers. They're opposites and 0. So you need to know the word consecutive. You need to know what integers mean. And you also need, of course, to know what odd and even numbers are. So let's look at some examples that go with this type of problem. Oh, let's turn to page 43 in our book. So this right here, it says go to page 43. And this is over this section, 2R3. It says integers are consecutive if each is 1 more than the previous integer. That's that first line. Integers are consecutive if each is 1 more than the previous integer. So algebraically, 3 consecutive integers can be represented as, our first number can be x or n, whatever. If the next number is 1 more than this number, the second number would be x plus 1. And then the third number would be 2 more than this number, right? X plus 2. So those are those first blanks. The very first blank says 1 more than the previous integer. And the second one, these are how you express consecutive integers. So if the first number is 5, the next number would be 6, 5 plus 1, and the third consecutive integer would be 5 plus 2, which is 7. 5, 6, and 7 are consecutive integers. All right, the next box down on page 43, even integers are consecutive if each is 2 more than the previous integer. 2 more than, right? Talking about consecutive even numbers. What if the first number was 4? Well, the second even integer would be what? 4 plus 2, and 4 plus 2 is 6, right? So the first number would be x or whatever, x, and then the second one is x plus 2 and x plus 4. Because like I said, what if the first number was 4? The next even integer would be 4 plus 2, which is 6. And then the third one would be 4 plus 4 is 8. So this is how we would write consecutive integers. And then when it says consecutive odd integers, the answers are going to be the same as if we started with an even number, right? Odd integers are consecutive if each is 2 more than the previous odd integer, 2 more than the previous odd integer. And then the expressions would be exactly the same, because if this were 3, the next odd integer would be 3 plus 2, which is 5. And then we would have 3 plus 4, which is 9. 3, 5, and I'm at 7. 3, 5, and 7. So the expressions don't change for odd or even. Okay, now let's look at some problems. So the first one says the sum in math means to add, 2 consecutive integers is 105. So 2 consecutive integers. So if the first number is x, the second number is x plus 1. right? Consecutive numbers. So then we would add those two numbers. There's the first number, here's the second number, is equal to 105. The reason it's plus 1 is because it's a consecutive integer, not odd or even. So now how do we get these numbers? Well, we can combine like terms. X plus X is 2X plus 1 equals 105. And then I would subtract 1 from both sides. So I would have 2X is equal to 104. And then how do you get rid of times 2? You divide by 2. So I would have X is equal to half of 104 is 52. So that the first number is 52. So X is 52. The second number, 52 plus 1, is 53. So these are the two consecutive numbers. When you add them, you get 105. All right. All right, what about the second problem? The sum of two consecutive odd numbers. So odd numbers, remember the first one is X. And what's the second one? The second number is X plus 2. X plus 2. So the sum of two consecutive odd numbers, so the first number plus the second number, is negative 92. So now what do? We combine like terms. X plus X is 2X. So then what do we do? Uh-oh, I didn't mean to change that. So now how do we get rid of plus 2? We subtract 2. So then our next line would be 2X is equal to negative 92 combined with negative 2 is negative 94. Then we divide both sides by 2. And then half of 94 is 47. So negative 40, a negative divided by a positive is negative 47. Oops, I wrote 2. Negative 47. The first number is negative 47. Negative 47 plus 2 is negative 45. Negative 47 plus negative 45 is equal to negative 92. Okay. And for all of these guys, if it's looking for two numbers, just divide this number by 2. Just divide this number by 2 and then figure out the closest odd numbers. Odd, not even, odd numbers. Since this says 3 numbers, what would you divide this by? You divide it by 3, and that would give you the middle number. The sum of 3 consecutive even numbers is this. You would divide this number by 3. That'll give you the middle number, right? But anyway, I'm just showing you how to write these alphabetically. I mean, algebraically. All right, but do it the easy way. Anyway, like I said, 3 consecutive numbers. So the first one is X, that's the first number. The second number is X plus 1. And then the third one is X plus 2. That's the third number. All right, so we would do X plus the second number is X plus 1. And then the third number is X plus 2 equals 345. Then we add 1 to 3 X's plus 3 equals 345. And then we would subtract 3 from both sides. So we'd have 3X is equal to 342. Then we divide both sides by 3. So X is 114, I think, right? 342 divided by 3, 114. So 114 is the first number. The second number is 115. And the third number would be 116. Add those up and make sure they equal 114 plus 115 plus 116. Make sure it equals 345. It does. Or like I said, the easy way to do it is simply to divide this number by 3. And that'll give you the middle number, right? That'll give you the middle number, and then you just go up 1 and down 1. Okay, that's the easy way to do it. All right, let's do the bottom one the easy way, not the hard way. All right, this is 3 consecutive even numbers. So I'm going to take what we got here, negative 228. I'm going to divide by 3. So 3 will go into 22 7 times. And 3 goes into 18 6 times. So it's obviously going to, they're all negative numbers. So I need 3 consecutive even numbers. Well, is negative 76 even? Yes, and that's going to be your middle number. So what's the number that comes before and after this? There you go. That's the easy way, right? All right, so then double check, make sure first, are they all even? And the answer is yes. Secondly, do they add up to negative 228? Well, add your answers together. And yes, I got 228. All right, and make sure if the answer is negative that your numbers are negative. All righty. Let's look at this one. This is straight from Hawks. It says, translate this English phrase, let Z be the unknown number. This, like I said, straight from Hawks, so it tells you what your variable should be. It says a number increased by negative 21 is equal to the quotient of the same number in 49. So let's start with a number, where's my pen? A number increased by 21, and then here's our equal sign, it's equal to. A number increased by 21, increased by negative 21, is equal to the quotient of that number in 49. So the quotient of Z in 49. All right, so this is kind of like one we did earlier where there's that divisor on the bottom. How do you get rid of divide? You can't pull that apart until you mathematically get rid of divided by 49. So the opposite of dividing by 49 is multiplying both sides by 49. 49. So this goes away. There's our Z is equal to, now we use our distributive property, 49 times Z is 49Z. And then 49 times negative 21, negative 21 times 49 is equal to negative 1,029. All right, now I want my variable on the opposite side of my number. So I'm going to go ahead and get rid of this negative or positive 49. The only way to get that to 0 is to subtract 49Z from both sides. So I bring down my negative 1,029 is equal to, what is 1 minus 49? 1 minus 49 is negative 48. So I'm going to, the last step is to divide by negative 48. Negative 48. Is that going to be a whole number? I hope so. First of all, what is a negative divided by a negative? A positive. So 1,028 divided by 48 is, nope, it's not even, but I can divide both of them by 3. I know that because I count up, I add these numbers together. 8 plus 4 is 12. Since 12 is divisible by 3, that means 48 is. And then also 1 plus 2 is 3, plus 9 is 12. That 12 is also divisible by 3. That means the whole number is. That's the divisibility rule for 3. So I can make the number smaller by dividing them both by 3. I get positive 343 over 48 divided by 3. 16, and that's probably as much simplified as we can get because they're not even. 16 is not divisible by 3. 4 doesn't go into 343. So I think we're good. That's as far as we can go. All right. And like I said, that's straight from Hawk, so you'll probably see that question. All right, so that's that section. And now we're moving on to 2.2. These are inequalities. So we've been practicing solving equations. Now we're solving inequalities with greater and less than symbols. So it says, what you do to one side, you do to the other. We know that. Solve inequalities just like you do with an equal sign, except there's one big exception. When you multiply or divide by a negative number, You flip your inequality sign. All right, so here we go. So this is, instead of having equal signs everywhere, we have inequality signs, right? So we want this n by itself, just like as if these were equations. You want your n by itself. What's in this middle section? This time there's 3 sections. So the first thing we're going to do is get rid of that -1, and we're going to do that by adding 1 to all 3 sections. All 3 sections. So -19 plus 1 is -18. Bring down our inequality just like we see it, 3n. -1 plus 1 is 0, that goes away. Bring down our inequality, and then 17 plus 1 is 18. Oh man, why does that keep happening? I'm a doofus, that's why. All right, sorry about that. All right, so now we have to get rid of 3 times n. What's the opposite of times 3? We're going to divide all 3 sides by 3. And we're dividing by a +3, so we're not flipping any signs. It doesn't matter if the answer we get is a negative. It just means what we're multiplying or dividing by. So 3 divided by 3 is 1, and 1 times n is n. So we have -18 divided by 3, which is 6. Bring down our inequality sign. Bring down our n, bring down our inequality sign, and bring down our, I'm sorry, -18 divided by 3 is -6. And then this is going to be +6. All right, so we're going to solve this. We're going to graph it, and we're going to write it in interval notation. So this is similar to our first class. So remember, we had our -6 here, our +6 here. Our n literally comes between them, and then this is where we do our open circle because it doesn't have the or equal to sign, to our +6 with a closed circle, and n is between -6 and +6. So how do we write this in interval notation? We start with our parentheses, we go through our +6 with our bracket, and this goes back to our very first class. So hopefully that makes sense. I'm going to erase this, move on. All right, let's look at the next one. All right, now we only have 2 sections this time, right? So think of this kind of, how would we solve this if it was an equal sign? Well, the first thing we do is get our variables together, right? So we have a 7z and a 4z. So I'm going to bring the 4z, I'm going to cancel it out, bring it over here. I'm going to draw my wall. All right, now what do I have? 7z minus 4z is 3z. I'm going to bring everything else down, bring my inequality down, and bring -12.8 down. And this is gone. We canceled it out. All right, I want that z by itself. So how do I get rid of -22.4? I'm going to add 22.4 to both sides. I'm going to bring down my 3z. I'm going to bring down my inequality sign, and then just put this right in your calculator, guys. Don't try to figure that out in your head. 22.4. You're going to get +9.6. +9.6. And now how do you get rid of ×3? We're going to divide by a +3. So z is less than 9.6 divided by 3 is 3.2. All right, so if we graph that, here's our 3, here's our 4. Our answer would be about 3.2, open circle. Our inequality would be going this way. What is that? That's a 4? Oh my goodness. What is wrong with my brain? I don't even know how to count my number line, you guys. What is happening? All right, how about this? Here's a 3, here's a 4. That makes more sense. There's about a 3.2, and my arrow is going to the left. My variable comes first, so my arrow looks like my inequality sign. And so how would I write this in interval notation? Well, down here is -infinity through 3 with a parentheses. So that's how you graph it, and that's what it looks like with interval notation. All right, I got to erase all this. moving on. Number 3. All right, now this time we see the word or, and back on that first slide, I told you that or means union, and when we see the word and, that means intersection. Okay, remember those from the first class? All right, so what we're going to do is use the distributive property. All right, so negative 5 times y is negative 5y. Negative 5 times negative 2 is positive 10. Bring down that inequality. We're just going to do this first problem completely, and then we'll do the second one. All right, now we're going to get rid of plus 10 by subtracting 10 from both sides. And then we bring down our negative 5y, bring down our inequality. 25 minus 10 is 15. The last thing we do is divide by negative 5. Now, when we divide by a negative, that's when we flip this inequality sign. So I'm going to write it right here. Y, flip that sign to greater than or equal to negative 3. All right, 15 divided by negative 5 is negative 3. Then it says or. Now let's do the second one. We want the y on the left side of the equal sign, or the variable, or the y on the left side of the inequality. So how do you get rid of a positive 12? You subtract 12. So bring down our y, bring down our inequality. 18 minus 12 is 6. So if we graph this, we put these in numerical order, you know that. All right, so y is equal to negative 3 or greater than, right? Or y is less than, open circle, less than 6. That way, forever. And or means union. That means all parts of the graph, all parts of this. So this would go this way forever, right? So really it includes, since this would go to the right forever, that means that it includes everything on the graph, because it doesn't have to just be overlapping. That's an intersection, correct? So this would be going from negative infinity through positive infinity. So that's what intersection means, or excuse me, union means any part of the graph that is graphed, okay? All right, and then the last one, so let me erase this. Now the last one's and. Now and means intersection, which means they have to have them in common, right? All right, so first thing we're gonna do is use the distributive property. So let me bring this up here. Negative 6 times w is negative 6w. Negative 6 times negative 1 is positive 6. We want to solve for w, so we're going to get rid of that 6. So then we bring negative 6w, bring down our sign up, we see it. 66 minus 6 is 60. So then we divide by negative 6. What happens when we divide by a negative? We flip that sign, flip it. And 60 divided by negative 6 is negative 10. All right, and then this one, we are going to bring our 11. Let's go ahead and write it right here. 11 minus w, 12. All right, so we're going to get rid of 11. So we're going to bring down that negative w, that sign, and 12 minus 11 is 1. But we can't have negative w. So how do we get rid of a negative sign? We have to divide by a negative 1. A negative divided by a negative is a positive, so that's a positive w. What happens when we divide by a negative? We flip the sign, and then 1 divided by negative 1 is negative 1. So we want to graph this. Negative 10 is way down here. Negative 1 is up here. So we were going to fill this in, and our arrow would go to the right. And then negative 1 looks like this, and then that arrow would go to the right. So this would go for eternity, but remember, it's part of the graph that they both have in common. So they have in common only from negative 1 through infinity. In fact, -1 is not included, right? But they both point to infinity. So that is what they have in common. Only the part of the graph where they have in common, which is right here. Starting from -1, but not including -1 through infinity. All right, I think we have one more slide. Yep, and then our study skills. All right, so here is, I got this off of Hawk, so this should be familiar to you. Now, I know I said always cancel out the smallest variable, but I want my variables on the left of my inequality. That makes it easier to graph. So I'm going to subtract 7m from both sides. So 5m minus 7m is -2m. Bring down everything else. That's gone. So how do I get rid of -6? I'm going to add 6 to both sides. So then I have -2m is greater than or equal to 7. And then I'm going to divide both sides by -2. So m, I divided by negative, I flip this and I get -7 halves, which is 3.5. So when we graph it, we're going to think of, you know, -3.5, but on Hawks, if you hover, it'll turn fractions and decimals. You'll be able to see them. So -3.5 is going to be right here. We're going to fill it in and our arrow goes to the left. Now, how do you write this as an interval notation? You go from -infinity with a parentheses through -7 halves, and it includes -7 halves. All right, number 6. All right, we're going to use the word or, which means union, which means everything graphed. So we're going to distribute this. So we have -4w, negative and negative is a positive. So we're going to subtract that 8, bring down -4w. 24 minus 8 is 16. Then when we divide by a negative, we get w is greater than or equal to -4. And then here we're just going to subtract 14 from both sides. So w is less than 15. So now if we graph those, we have a -4. It includes -4. And it goes to the right forever, forever, forever. Oh, what am I doing? Dang it. What was that? This was a 5, right? All right, so this goes forever to the right, and then we have our 5 that goes to the left, and it says, so it's a union, so it's any part of our graph. So that's from -infinity, because this goes forever that way, through +infinity, because it's a union and it's any part of the graph that's graphed. All right, one more thing, number 7. Let me get rid of all this. All right, now this one has 3 sections, so we got to do everything to 3 sections. So we're going to start with -3. So we're going to add 3 to all 3 sections. Bring all that down. We have -21. Our sign, this is gone. And 9 plus 3 is 12. So then we're going to divide every section by 3. So -21 divided by 3 is -7. Bring down our sign. We're left with y. Bring down our sign, and we get 4. So then when we graph that, we have -7 and 4. So -7, our graph goes to, think of it as the opposite. So when the y, remember when the y doesn't come first, the arrow goes in the opposite direction. So the -7 would go that way, -4 would go this way. And it has to be just this section because the y is in between -7 and +4, and it includes +4. So the y is in between those two quantities. Whew, that's a lot, you guys. All right, hopefully you guys can do those. Hopefully, I should have said stop the video and practice those 3 on your own and then check your answer. So it's always helpful whenever you can do that. Try to solve the problems on your own. All right, and then tonight we're looking at the study skills section called Practice, Patience, and Persistence. So in your book, you'll find that on Roman numeral, what is that, 17 XVI. So read that little section. And then the 2 questions you have to answer, send me a text through remind.com. What is another area not mentioned here that requires practice, patience, and persistence to master? Can you think of anything you could master without practice? That's a good question. And then number 2, can you think of an example in your study of math where practice, patience, and persistence have helped you improve? So any kind of math you've done, whether it's in school or out of school, on your work, on your job, whatever. All right, and please send those answers to the remind.com. So that's 4. This is 4th response. We'll have 6 more and then we'll be done with these for the semester. All right, you guys, make sure you join me at 6:50 for our class. If I can be of any assistance to you before then, let me know. And I will see you guys later at 6:50. Thank you.